because I reached 50 to 60 viewers, obviously. I'm listening to music right now. It's Katy Perry. What is it called? Dark Horse. So that is what that is. So obviously, what do we got going on here? Let me show you. Let me let you know. Obviously, 0 viewers right now. We got 100% pure palladium PD46. There you go, right there. 99% pure, as you can see on the bottom. 99. You can see it. 99% pure, and obviously, it looks different from the screen because it automatically goes opposite. Obviously, one of the unique things about electronics, sometimes they make big mistakes in big way and people get harmed. So obviously not harmed, but they can't read in this instance, reading like something. So obviously we got special edition purity 99.9%. That's pretty high. 106.42 Palladium PD46 ordered from 119 PE guys from, of course, Israel in 2020 or 2021, sometime. I'd have to look at my books. But basically, we have it wrapped here in the tinfoil. And the point of the palladium is because it's a pure, stereotypical element, right? It's a cohesive, or it's basically, a stable metal, that would hold around any element. I mean, glass, molecularly, right, with sand and molar structure that makes the glass. Obviously, metal as well. Obviously, or also would just fall apart because it would be tonal, right? So in this case, it's a LaCroix, what's it called, pure water, sparkling water. Obviously, well, let me show you. Also. Made in the United States, if you want to read it. Obviously, it's backwards, so you can't. But as you can see, it's corrosive, so the metal can just break apart really easily. So the point of it is not to let that happen. So that's, molecular structures, chains, right? Same thing. And then also, substances like water. This one, oxygen is another. We wouldn't, usually call oxygen a substance, right? You would call it a substrained element, right? Because it's gaseous. So basically, and also a collusive liquid, so like water in a teeped structure, like water in. Technically it can, or a glass that's a lipid, like that means that like it curves out, right? Something like that. So basically we have a focused signal, like palladium. So that's number 46, the element. It's a derivative of like a molar mass, something like a chain of something like what is it called? Plutonium. So it's kind of like that. It's kind of half the derivative. It's almost half the half-life almost, but it's not. So what does it work like? It works like something that would transfer energy, but would not. It would be constable, so it would have a positive, negative, and then a recurrent negative charge, like that of a cleaning chemical, or something like a substance of energy protocol. So it's inand, and then like rearranged like RNA versus something like neurotypical. So it's Na. So what is Na? Like sodium. Sodium is Na. Oxygen is Na. Anything byproduct based or that has a systemic lubricant, so something like that has aluminum in it, or other things like that are biological. So I'm going on and on, obviously. The point of it works like a filament, basically. Why does it work like a filament? And obviously, I'm going to stop me right now. I have 0 viewers, so if you're on a VPN right now, turn off the channel. Support people in IRL, real life. Just don't watch other people's things, and you've got 0 viewers. This is for recording purposes only, so go back and rethink things. So basically, what I was getting at is. It's a filament, basically. So what makes it different than any other filament? When you arrange it, it basically has a sonic element to it. Like, I mean, it's like make any noise? Probably not. I mean, it's an element, right? It shouldn't make any noise. It shouldn't vibrate with the earth. I mean, it could have gravitational pull like anything else, right? Chains or electrons, neutrons, all of those, one piece, which is a big deal, right? It does, show there is some sort of vibration, within the element. Like chemical burn is like that, carbon is like that. There's a lot of things that are like that, basically. And again, 0 viewers, or a thumbs up here. So basically, I have, of course, the element wrapped in tinfoil here. It's touching the tinfoil and it's wrapped in plastic. So when I take the plastic and I'm going to put it on the tinfoil and wrap it up one more time, obviously to illustrate, the purpose. So why the element wrapped up into, segmented, wrapping? So like, why would you, have like two processes versus one process? So, carbon like chain, right? You would have, two products versus, one sustained product that fits a loop of or electron, right? So that's like two nanoparticles, right? Or one particle, right? Versus like one electron. You wouldn't equal those out, but in biology, you don't have a choice. Those things grow together. They're systemic or systemetric. There's a difference between those things. So basically, the aluminum tinfoil works like the plastic wrap here, but it's biofocused. So basically, it duplicates. And they're like, well, what would be the difference between this and doing it with plastic instead? Is it safer? So, well, yeah, it is safer. But I just chose to do it with. I chose it to do it with tinfoil. So I have the palladium here. It's 46 PD, Palladium from Israel, obviously, from 2010. I mean, purchased fairly. I think it was $100 for a gram of it, or so. So they sent me this, and this is what I have here. So it's the tinfoil plastic wrap, and then the tinfoil again. So it's palladium. So it's also constructive or has a constraint with the atomic element like any other atomic element, meaning it fits decimation. So that's like 0.0. So when you have a constant with an electron, it fits a diamass. So that's particularly when the electron is big or small, right? The covalent bonds are structured like that. So they're kind of like indexed differently within each chain, obviously, because they're like kind of nanoparticles, right? So the construct kind of works like pasta in a way. It becomes soggy, or it becomes tense when it's like cold, or in some cases it becomes definite. So like it's good pasta, or it's just dry pasta, right? Same as programming. You have dry code and then you have wet code. Same as a product. If it got wet, it's wet. If it's dry, it's dry. Do these things fit together? They don't fit together. So when you look at the spectrometer, like, kind of the loop of like, looking through the lens basically, and then what's the point of that? Well, you have something that, settles the molar, segmentation of like sensation. It's kind of like a hypothesis that's like kind of the framework. It's kind of like, looking through glass basically, which it is, based on, kind of the same structure as molar mass, right? Glass is like a shock resistant thing. So it can break an electronic. So if you tap like a phone or a watch to, a piece of glass, a certain type of glass, it will automatically shut off. It will break like some sort of resistor in the circuit, right? And it creates, power surge or whatever you want to call it. It's like an EMP almost, but the surge isn't protected. It's not grounded by a loop, right? Which is the electronic spectrometer. So why? Because it needs to have the same element or filament in it, which is, what's a resistor is made out of. So basically, this atomic element, works like a piece of metal wrapped in plastic. What's the plastic? Well, it's a slow-moving mass. So it's kind of like water, right? So it basically, it's a hypothesis or a hypochambered, like, how do I explain it? It's like kind of like a mass that has a spectrometer of its own. So it's like kind of growing 1 to like 1.6, and then it kind of like, it's radioactive almost. It kind of runs on a spectrometer that is like heat exhaustive because the plastic is expanding. It's cooling just the metal, so the heat element there is focused on like a diatrading system. So it kind of like goes a 0.01, 0.101, and then it kind of shows off like a color mass. So it's kind of like a carbon chain. So basically the 46 PD palladium, it's kind of like carbon in a way. So it's kind of like what you would get from calcium residuals or something like dirt. I mean, necessarily you might be able to consider like cotton or something like human, right? Human is like that. Cartilage is a little bit like that. Skulls like that. Other things are like that. Obviously. So what would you call that? We call it like a deca system. Like you wouldn't call it like a log because that's usury. So usury is like an attention. So usury you would use like within water, right? Historically, like if you're graphing water concentrations, historically you'd have that. But a usury would also have pivot points. So those pivot points are like things you can input information per 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 container. So kind of like array or function. You put the container in there, and then you would fit. So the illustration there was basically the construct is usury. So it has attention, it's attentive, it can be defined. They didn't make it strange, so it's there. But basically, with those numbers, they add up to technically nothing, obviously. So that's what it is. So basically, the plastic wrap there is built on like water. So without water, you wouldn't have a construct of a pH scale, right? A pH scale is scalar. So the scalar, pH scale, like that of water, saliva. I mean, oxygen is the same way. Plant matter is the same way. Some dirt is like that. More clay-based dirt, obviously, because it's more usury defined and it's a byproduct. So gas is like that, but I mean, if you were to test for gas, it would check for everything, right? It would check for, anything usury, right? So it could be, attentive, like, a towel, in the trash can. It could be, you could count anything. You can count biomass, bioproduct. That's a lot. And then when it gets down to more usury products that are undefined, like butter or other things, because they have a lot of protein chains in them. That's amino scales and things like that. They're uncountable, so you would count it through byproduct. So that's kind of like, how much you put in a product. You take pictures and kind of do that because it's undefined. It's net versus gain, right? So like in the United States, we have an ounce system, so that would count like instead of like mass of like a gram, right, or kilogram, you would have like an ounce versus a pound, right? But they go together. Oh, they go together like half versus I think it's like volume versus product or something. It's more of a market consumer, right? So in some instances, so I mean versus net gain, it's a little bit different, and it has a usury input into it. But basically, the P chain, the protons, right, in the structure, especially the first wrap, the metal here, and the second wrap, the plastic, they have what is like a beta chain right here because of the metal reaction to the corrosive effects of the palladium. And you're like, why does it have palladium effectiveness? Well, it's because it's like water, right? It's also hydrating the water situation. So that means the molecules in the fiber here, like what I'm touching, it's all corrosive. It becomes a beta signal. And you're like, what's the construct of that? That's in the hundreds of atomic structures. So that's like kind of the fixed signal of like heat, right? The exhaustion in Celsius system is like 100 versus like 0. So 0 is also 100, but it's not. 0 is obviously. Why is 0 versus like 100 versus 0 on instance of like 100 versus 0 in something like a beta chain, right? Well, I guess that's because it's carbaic, so it could have been made with lithium. It could have been made with iodotic acid, right? Those things, fit the function, right? So it's usually the case they're made with those, right? Like teeth are made with those, like it's more pure. It's an easier way to calcify, material in metal, obviously like iron reduction. It's a lot better. It's more expensive, but it's better. So, I mean, going on, I mean, you could, claim the water here, is resistive. So going back to the zero, again, I have 0 viewers, I'll give 0 thumbs up, so it wouldn't matter if you watched it or not. So basically, the function here is 0 versus 0. So, the zero chain, effectiveness, the calcium buildup, and it's and what else? What else is there? There's the zero product it will make. Like why does it make zero product? Well, because the chain is kind of like mimics the signal, right? So the beta, the beta always mimics, right? It's 100 seashell. So basically, that's kind of like how the temperature gauge works. So like, what does that even mean? So basically, the 1B, 2A signal, it's like kind of like, the percussion of like, like a chemical ignoring another chemical, or an electron, ignoring another electron, right? It's like a anion versus another anion that can't commit to a proton shell. So basically, that 1B flips to what would be on a degree mass, right? And it wouldn't go to 100 or 150, it wouldn't go to 50 either, it would go to 120, it's set in the periodical element hierarchy, right? But it's not exactly 120, it's like 126. So basically, that basically, focuses the tonic structure mass on like something that's like white, focused, basically. That's basically the chemical insistence of like salts, or like the construct of carbon versus, human existence in a shell way, kind of like how carbon works, kind of like how it shells together, basically. Have you ever held pure carbon in your hand? Probably not. Probably eat through your flesh, obviously. But no, the construct is similar. So basically, what we have here is the palladium element, 99% pure, obviously. So the construct of, 0.0 mass and, the 0, Celsius chain, whatever you want to call it, or the bifocused, right? Heat exchange, the segmented, chemical reaction, which is beta versus, the carryover from neutron to neutron, right? In this instance, the last two shells are neutron to neutron, not anion or anion, or proton to proton, yes and no. It's range and exchange, so that means it's usury, and then also has some defined heat exchange, unlike non-defined heat exchange. So what does that mean? That means the biomass isn't mixed correctly, but it is countertonic, so it does structure or place usury. So it's the material is breaking apart. Obviously there's a half-life to it. Monofocus, shows, it's probably the molar mass of the product. The factor is, if you mix, two chemicals, one with one and then the other with half, the chain reaction doesn't fit. It's like kind of mixing 46 by part, like gasoline, to 0.46, something like in diesel. Would it work? It wouldn't work, but it would zero out your engine and then it would exhume all the flames. So kind of like, burning your gas and kind of like mixing it with modular glue. So basically it's a hold together. You could put alcohol in there. Would it burn off over time? Yeah, it would burn off over time and it'd work. Yeah, it would make your engine black. Yeah, it would make your engine black. Would you be able to use it anymore? You wouldn't be able to use it anymore because it would be in a different type of molar mass. And molar mass is like set at like the whole system, the engine and everything. So like it's all exhumed, right? There's like simple parts in the engine, right? Like the hose and everything. They might not turn black because they're made out of plastic, right? So it's slow moving. They don't just bake into the engine. Parts like, metal, iron, those are reduced to ferrous, so they have ferrous metal like salts, sulfur in the engine parts, and then roommates, oxygen, which are kind of like the molar mass of like marble, right? Do they work like that? They don't. They basically bake into the engine block. There's not really a good way to get rid of it. Then with gasoline, you get rid of it. No, you don't do that. So even if you soaked it in water, you'd rust it. I mean, obviously, that shows this ferrous, metal or something in the environment. So, yeah, so going on to the last shell, the internal shell, the metal inside of it. So it's kind of arranged, obviously, the metal on metal. It's deranged. We have P2 on the tinfoil on the inside, and then the plastic on the middle again. Then the palladium inside, and I can show you what the palladium looks like. There's another piece in here that I can show you what the palladium looks like, obviously. Oh, slip it over so I don't spill anything here. And I've just had this around for quite some time. I've even, tried some simple things. I tried soldering palladium to like, a magnet, like a little ball magnet you might see. But as you can see, this is what the palladium looks like. It's one grain here. And it's not this circle, the semi-disc, it's the square piece right there. See, you can see. And it's even marked one grain, 1GR, P. I'm not sure, PD. Yeah, 1GR. I can't really see it. But 1GR, something like that. It's PD. And then there's wire here, and there's also dust, palladium dust. And then there's these half circles here. So I haven't touched it in some time. I've just been doing schoolwork for logistics. So, the point of it is, the palladium is biofocused also. So it's environmentally strong. It's like a reactive force. So it holds stable in something like the environment, right? So it's constrained, like it's constrained because, it doesn't have like a focused purpose. Like it doesn't really react with the environment, doesn't react with other elements, right? It's neutral. It's a very neutral chemical or element, right? The focus is, 1B, 1, 2, and that's normal for a neutral element. I mean, a person showing those exhibits, like having beta, radiation in them, they probably wouldn't enjoy their life, I'll put it that way. So you're like, what is the one way to, fix that? And you're like, well, you would have to have like a conotonic, like pentameter to the structure, right? So it's not like wire or like soldering something to something or adding it, like putting in something, right? Which you could, but it would burn off the exhaust of the chemical. Obviously, it wasn't molarly sound, and some what you might consider soft science, right? So what does that equal out? It equals out to like the chemical getting colder, right? That chemical, is constructed like from different elements. Sometimes maybe cotton is used, like cotton resistive acid, right? Do those always work? I mean, not usually. They're less clean. They collect more bacteria, and obviously more dead things attract to cotton or other things. I mean, it's like, would you like go after a target that has cotton? Probably not. I probably wouldn't mess with every signal in your environment, like something like a weed signal, I'm not a weed signal, like posies, like, they used to represent graves, right? Because they would always grow around dead soldiers' graves in World War I, World War II. And so it's more constructive towards that. And you're like, why? Well, because you could also see that, they seed around dead things as well. Exhume, they're anthratic, they're attracted to it basically. So you have that construct there. Even like your dead animals, they're probably attracted to it. But I'm not one to choose. So the construct is the same. The cotton, facilitates, like maybe something that's like, breeding, the connotatic acid in the human body, or maybe another animal, right? So it's a guessing game. So the cold compression is usury again, obviously. So it fills out the exhaust, in the model, obviously. So what we have here is the first shell, which is 2p, and then it has a huge or hugron, like ion, or I'm not sure what you call it, like Hughes boson. I don't think I would call it that. I wouldn't go that far. And again, I have 0 viewers, 0 thumbs up, obviously. So basically, after learning the effectiveness of like cotton or dandelion, seed, I guess, you come to this video and you're wondering like, what is up with palladium? What is it, Austin? What is palladium for? What does it do? Okay, let me talk to you about the first shell, and this is just through the basic, concept here. So take like, these cranberry seeds, obviously. I'm not afraid. I'll put the handwriting in there. It's not that difficult. The Palladium at least. So we'll take the cranberry seeds, and then we'll take the pumpkin seeds here. I could put it on a plate. It would hurt less, but let's take the cranberry or the pumpkin seeds there. And then basically, we have the cranberry seeds or the cranberries themselves. They're monofocous. So basically, if I may explain, they sit. So basically, they're shaped and formed by basically it's constructed from the pentameter, which is the environment, the water, the coarseness of the environment, obviously, which is the function of it, like things that are in the environment, what's in the way of the environment, planning and staging of the environment, and then obviously the construct of the environment, which we already went over, which could be like elements in the environment, right? Constructiveness. Those change, in human relations, some models of logistics, they change, not the good ones change. The ones that are effective stay particular to logistics. So basically, that matches like a cold schedule, right? So it means it sits. The cold doesn't move, it sits on the exact ion right here, and it sits. So it's that P2 signal. It doesn't drive, it's just sitting here. It's a chain, it's focused, right? It's scheduled here. So basically it sits. The P2 chain also reacts like a wire. So it's cold, hard, and absorbs energy like the color black, right? It doesn't emit it, it's the color black, right? The metal is like the color black. So basically it fits and it doesn't vibrate or just, it just emits the alpha, which is the chain here, followed by the beta. And then it kind of goes through the elements up to like around 26. It doesn't add, but basically the combination of the P2 and then the first P chain, right, the proton, it reacts like glass would. It shocks the ions in the element, right? You're like, what's causing this force? And the radiation bounces off of the radiation here from gravity or other focus like heat, exhaust, energy, vibrations, all of it, the chain of in the environment basically, and then it sits. So does it do anything if it falls? I mean, we hold stable. It's not like vibrating, shaking right now. It's not really hot or anything. But let's say like if you took like this pumpkin seed, like it has like it sits right here, it's shaking a little bit. It's not shaking, but basically it sits. The function is like frictionless, right? Because it's frictionless. So you see it's conic. So that means it like has conic acid on it, or it has something like a construct that basically doesn't seed, but I mean it has a chain reactiveness. So basically the selectiveness of the shell is conotonic. And again, like a lot of people don't write it down because it's not focused, right? It just seems like the same thing. It's not. So basically it could break apart, could not break apart, but it shows it's measured through diomass. So that shell is around like 40 in the range of like atomic elements, right? 36, 40, around there for a normal chain. An abnormal chain would show 42. A neutral chain would show like 46 or 50, which are contic. So that's how you would make these royal metals that are meant for like rings or other things. And you're like, why is that? Because they sit atomically, so 150, 100, 50 are all stackable. In human organic, structured logistics, you'd stack, chains that are metric on top of each other. You're like, why is that? Because they function in a protocol that are like, atomic in structure, right? Like one, is like the cow. One is the chicken. You store the chicken on top of the cow? Probably not. Do you store, human on top of human? Probably not. Glass on top of teeth? No, I don't think you do. So, I mean, it basically prevents it from falling apart. Is it going to fall apart no matter what? It is going to fall apart no matter what. But the chain still stays effective. So say like you have an environment where the cranberry sits on top of the structure, which is the basic structure for the pumpkin seed that's broken up with salt on it. Obviously, the cranberry has sugar on it, and it's constructive. So basically, it means it collects and then it itates. So what is itate? Like, well, it basically means that the signals functioned or push, right? It's diabating, like salts or the combination of chemicals, basically. Like skin versus skin reaction or, other reaction forces. So basically, what does it do? It basically sets water versus, other significant factors. I wouldn't go as far as to say, if it's, particular masses, I wouldn't say like it fits 46. I wouldn't say it fits 50. I wouldn't say it fits 176, 150, or anything like that. I mean, like if you do simple, like if you mash these together, maybe it will fit 176. Would it? In real life, I don't think it normally happens like that. But they fit together like, atomic elements. So like 20 versus, like something that's ceramic, right? So ceramic would be like 56, right? It would fit like plastic, right? Like marble is kind of like plastic, nails are like plastic. Derivatives of oil, organic matter, carbon are like plastic. Metal is like recessive or resive. So it's kind of based on like iron or ferrous elements, like that's substance constraint. Like that's how the Greeks developed substance or atomic matter, right? They said, what is the easiest way to break apart something and what's the best way to put it like that? So that's kind of how that works. The Greek Empire, ruled a lot of places, the Mesopotamia, all those things, and this were the places the people lived with. And then the Romans didn't really go after these elemental designs or fundamental like republic rights organizations, but that's what it had. And the Egyptians are a little bit different as well. So basically, so you have the construct of this element, which is the filament, right? The first element, or the first wrap, which is the metal, basically it oxidizes. So there's the P1 chain, the P2 chain, and all these little derivatives that flatten the signal, right? Stay cold, they stay dormant, they're of course absorbing energy. The resistive, so it shows you, it's kind of tonic, like 150, it's like calcium or water, or something that's valued like at like a starch, something you would consume possibly, like a bicarbonate substance, like something that's been produced, like like a nutritional supplement, or eating something out of glass, right? If the glass is more effective based. Some cases metal with its wrapper, right? So the 1p2 signal is now dissipated. It's molar, so that means it's statonic, meaning the chemical is like one, right? So it reacts with another chain there, and then it goes to that two protons, right? And then it stays within those neutrons. So the particular fashion of it is kind of like, they're flashing each other, right? Like the chemicals are flashing the other chemicals, right? But they're not. They're granular. So I mean, that's what a granular grain is meant to do. It's supposed to be used for chemistry. So basically, it works as like seed. Like it has the same volume as a seed. They might have made it same. Like 1.46 versus 0.56 stearic acid, something like that. Something a normal person would arrange, like, a normal cook might use like a lower mass of that, for cleaning, something like that. In some instances, they put it in bread, obviously, for like pasta and things like that. It's more in Europe, obviously. That's why people don't agree with sharing wheat and all those things. They germinate. Nobody likes pesticides in their food. Obviously, preservatives are the same. So the 1p2 signal here, basically, it noates. So basically, it works like a crystallized subject. It propagates. The plastic basically takes that signal and resonates it. So, no, it's a shell basically, electron. It's bundled. It's bacterial in a way. So it has phosphate, carbon, stereolic acid. It's kind of like human reaction. It has some sort of human element in it. And then it has like, the molar mass, which is carbon or cotton, right? And so in some instances, that's the case. In some instances, it's like more of an F2, right? Like for a carbon or something like a illusionary or a illusionary. So that would be a bicarbonate product, like kind of like the mass of this, or something stereotonic, which is none as well. So that mass or that matrix is like glass, right? So that glass is like broken up metal, bicarbonate, something that's functioning but not functioning. So there's like a little derivative there, which means it doesn't absorb all the energy, doesn't absorb all the color. It's something stereologic. I keep coming up with these gravitational words, whatever you want to call them. It's like magnetized, basically. So basically, it's like functioning like, something that has weed in it. So why weed, why metal? I guess it's part of the chain. So it's kind of like if you ever pull the muscle, right? Like it's like kind of like, one part of your muscle works with like, the magnetic issue in your leg, or, your phospheus structure, like your phosphate structure in your leg. And then the other works with like, gains, like electrical gains. One works with energy, right? Like the blood vessels. The other one works with other water, maybe water. So the particular mass is like kind of muscle in a way, but 1p2 obviously, and then you have the beta gains waves, kind of like a carrot would be, kind of like battery acid in a way, and then plastic as well. So the 1b2 also is, shows that there's water mass in the actual function of the elements, and again, that's typical for anything in the real world, IRL. That shows molar mass. That's glass, right? Is its derivative? It's made in glass. Again, every atomic element would have to be mass produced and at a level that's decentric, so that would be made in open container, react with with the environment. It would just be found in the environment, right? That's stereotonic, right? That's something that you would find and be defined easier, be substance. So basically, with the V2, the P2, and then you have the one chain right there, the 1 and 0.0. So what does that mean? Why isn't it defined? Well, it's defined in a ratio, right? Because the particulars of the palladium here are functionable. So like they're constructs of two chemicals, which are like bicarbonate and then a product of chain reaction. So why is it product of chain reaction? Because it's one substance. That's how it's made or found, because it's a I guess less of a way to risk the element that you're combining it with, which basically means it won't react, create a phosphorus, chemical. It won't debunk the chemical, meaning like it won't register something else when it's made. It won't oxidize and turn into a different frequency, which are like souring, like something is kind of similar. Kind of like the construct of not being able to register something. You can't register an element that hasn't been made. You usually need to use it, right? So the construct is dipolar, right? The construct is water soluble somehow, at least. So the chemical, it's not really the chemical. It's the chemical, but not the chemical. But the structure is significant, right? So the positive charge of the element, even without the wrapper. With the wrapper is a little bit different, right? The construct is positive. So it has positive elements, positive protons, it has neutrons, and then it has anions obviously has anions. Every chemical element has anions, no matter what. So the construct, is similar in purpose, like friction, right? But it's porous, and it has a low rate of like combining with things. FST, glassware, it works that way. It's kind of like burning off bicarbonate mass, right? That's like black metal or carbon in some words, or metal. It's like iron, silver, phosphate, different chemicals, iron, steel. Titanium is more gallium rooted, so that means it'd be more productive. And you wouldn't technically use a combination effectiveness with a phosphate, like aluminum either. So the bicarbonate here is corrosive. So maybe, the chemical is made of steel, or, maybe aluminum that's made incorrectly. The molar mass is indifferent. Aluminum is more of a biomass, right? So it can make porous. So it means you use the same molar mass. Each time it's easier to make, and the glass is more functional. So why would palladium be different? Because it's made with plastic, maybe. So the coarseness of, the plastic, the other elements in the palladium, water, the bicarbonate, they all show the residual of the substance to be broken down more than 46. The root of it is, like a rat, right? It's something, indifferent, kind of like the frequency or tone of, kind of like metal that is stereotypical, like something you find in a headphone, that vibrates or stays together. It's exclusive, kind of like cardboard, starch, maybe. It definitely has that 1B signal, or the beta, radiation effectiveness to it. It also has, substrate like that works like corn, so that B2, P2. And then, now I'm thinking it's E, like it's rather related to significant loss versus mass versus rate versus, total loss, or constructive functions. That's basically water. Water would burn off after a hydro, carbon effectiveness, or hydro, peroxide, whatever you want to call it, seed carbon, basic, roots of seeds, or, plant matter. It would do that. So what would that mean? It's water. It could be nuclear radiation. It's biocarbonate. The beta would technically work that way, but it wouldn't. So cotton would work that way in most cases. Some cases, at least, wood would work that way. The constructiveness of the focus of elements would also work that way, because that's how they're built. Kind of like baking soda, it's built like that. And then B2, also corn works that way. A lot of products work that way. B21, also the same. The chain is more molar in some. So it is what it is. So it's been 43 minutes. I'm gonna take a break here.